Okay, good morning. In this video, we are going to discuss about a problem from consolidation. So the question is, in a lab consolidometer test on a 20 mm thick sample of saturated clay taken from a site, 50% consolidation point was reached in 10 minutes. Estimate the time required for the clay layer of 5-meter thickness at the site for 50% compression if there is drainage only towards the top. Assume that lab sample and the clay layer at the site are both subjected to same increase in stress. How much time is required for the clay layer to reach 90% consolidation? And what is the time required for the clay layer to reach 50% consolidation if the layer has double drainage instead of single drainage? Okay, so in this question, a sample was given. The sample has a thickness of 20 mm. And it was said that in order to reach 50% consolidation, it took 10 minutes. Now we are asked to find out same 50% consolidation of same sample, but it is at a site. So the thickness of the sample become 5 meter. Instead of 20 mm, it become 5 meter. Now we have to find out the time required to reach for this site sample of 5 meter thick when there is drainage only towards top. Okay, so that was the first question. So here in this question you have to find out three parts. First part is to find out T50. T50 means time required to reach 50% consolidation for a sample of 5 meter thick. And the drainage condition is single drainage. Single drainage means the drainage is only towards any one of the side, either towards top or bottom. Okay, so that is the first question. And in second question, if the lab sample and clay layer are both subjected to same increase in stress, how much time is required for the clay layer to reach 90% consolidation? So we have to find out T90, time required to reach 90% consolidation for the same sample of 5 meter thick. Okay, and the third question is, what is the time required for the clay layer to reach 50% consolidation? The same clay layer of 5 meter thick, but the drainage is double drainage. Okay, so these are the three questions that we have to find out the answer. Now let's see how can we do this. So here I am writing down all the values that is given. So I am indicating T50S, which is indicates that it is the time for 50% consolidation for a site sample. And T50L means time required for 50% consolidation for a laboratory sample. Okay. DS means drainage path for site sample and DL is the drainage path for lab sample. So here it is given that for a lab sample which is 20 mm thick, where the DS is lab sample which is 20 mm thick, we have the time required to reach 50% consolidation is 10 minutes. Okay, so the lab sample drainage path for lab sample which is 20 mm thick. 20 mm thick, we have time required is 10 minutes. Now we have to find out what is the time required for the site sample to reach 50% consolidation. T50S is to be find out. So we have an equation, basic equation, that is TV is equal to CV into T by D square, where TV is a time factor and small t is the time required to reach that much percentage of consolidation. D is the drainage path. If it is double drainage, we will consider the thickness, D will be thickness by 2. If it is single drainage, D will be thickness itself. Okay, so in this question, 50% consolidation, that is TV is the time factor required for 50% consolidation. CV, coefficient consolidation, is also same since we have same sample. So same sample means CV will be same. Okay. Now what is T? T is the time required for 50% consolidation and D is the drainage path. Okay. So we have lab sample and site sample. Here TV both are same since we are considering only for 50% consolidation. CV both are same since same sample is considered. So coefficient is same. And T50 is given, which is 10 minutes, and T50 for lab site sample, that we have to find out. T50 and D. D is the drainage path. In drainage path, it was given for double drainage. Okay, double drainage path was given. It was 20 mm. So here D will be, when we consider double drainage, D will be thickness by 2. That is, thickness is 20 by 2, which is 10 mm. So here we have D will be 10. And now in site sample, it was mentioned that it is only having a single drainage system. So our drainage path will be 5 meter itself, total thickness. Drainage path will be H itself. H is 5 meter. When we convert it into mm, it will be 5000 mm. Okay. So we have all the values. Now we have seen that both TV and CV are same for both samples. So we have to deal with only T50 and D, drainage part. Okay. So we found that TV by CV are same. So we can write from this equation, we can write TV by CV is a constant, or which implies that T50 by D square will be a constant. So we have reached equation number 1, that is T50 of the sample in site by drainage path square of sample should be equal to T50 of the lab sample by drainage path of lab sample. Okay, so we have this, we can find out the time required for site sample from this equation. T50 of site is equal to T50 of lab into D square by DL square. Okay, so T50 of lab is 10 minutes. D square is 5, DS square means site samples drainage path is 5000 square by DL square, lab samples drainage path is 10 square. So we will find out the total answer, it will be minutes. Since this time is in minute, we will obtain the answer in minutes. 25 into 10 raised to 5 minutes. Okay, now we have to convert it into years. Since it's a very big number, we are converting it into years. So 25 into 10 raised to 5 by 60 into 24 by 365. That much years will be there. So we have found that it is 4.76 years. Okay. Now let's come back to the second question. The second question was T90 for sample of same thickness. Okay, so we have T50 is there. We have to find out T90. So we have the same sample. So coefficient in this equation, coefficient is same. But TV, what is TV? TV is the time factor corresponding to the consolidation, percentage of consolidation. And this value you should by heart it. For 50% consolidation, TV, that is time factor value is 0.196, and for 90% consolidation, time factor value is 0.848. Okay, so now we have two samples, that is a same sample, 5 meter thick, single drainage, but the thing is we have to find out the time required for 90% consolidation. So CV is same, since the sample is same or drainage path is same, so D square is also same. So we can find out that in the second question we have only two values which will vary, that is time factor and the time required to reach the consolidation. Okay, so here CV is same, D square is same. So we can write CV by D square from this equation. CV by D square is a constant, or we can also write when CV by D square is a constant, TV by small t will be also a constant. Okay, so here TV by t is a constant. So we have 90% consolidation time factor and time required to reach 90% consolidation, and 50% consolidation time factor divided by time required to reach 50% consolidation. So in the just before we find out that 50% consolidation for site sample whose thickness is 5 meter single drainage, 50 in order to reach 50% consolidation it will take 4.76 years. So here we will find out T50 is 4.76 and T50 we know the value 0.196, capital T90 which is 0.848 we have to find out, small t90 which is the time required to reach 90% consolidation. So T90 will be, when we cross multiply, you will get T90 into T50 by T50, right? So here T90 will become 0.848 into 4.76 divided by 0.197. The value is coming around 20.4 years. Okay, so that was the second question. And what was the third question? In third question, it was find out to ask, we have to find out the time required for the same clay layer of 5 meter thick double drainage, but the drainage will become double drainage. So they want us to find out the time required for the clay layer to take to reach 50% consolidation if it was in a double drainage condition. So in the first question, we find out the time required to reach in single drainage condition. So what will be the time required for the same clay layer if the drainage path was double drainage, or if the clay can drainage in both direction. Okay, so we have time required to reach in single drainage T50 4.76 years is there. Drainage thickness is 5 meter since it is single drainage, right? So for the same clay layer, so the CV is same, since we have to find out 50% consolidation itself. So TV value is 0.196 or 0.197 also. So TV is same, CV is same. So what is here? What is the constant? TV by CV is a constant. So we can write from this equation TV by CV is a constant, or we can also write small t by d square is a constant. So T by 50. For in order to reach single drainage, T50 is known and thickness is 5 square. But for double drainage, what will be the D value? Since it is double drainage, thickness by 2 will be the D value. So thickness is 5 meter. So we can write 5 by 2 which is 2.5 meter. Okay. Since both are in meters, I am not converting it into mm. Okay. So here we know the answer 4.76 which we was, so sorry, this T50. In order to reach single drainage, T50 is known, thickness is 5 square. So if it is double drainage, D square will be 2.5 square. So T50 is to be found out. T50 will be, when we just cross multiply it, we will get 4.76 into 2.5 square by 5 square, which is coming around 1.19 years. So a clay layer, when its thickness is 5 meter thick, it will take 4.96 years in order to reach 50% consolidation if the drainage is only single drainage. And the same clay layer with same thickness, but if the drainage is in double drainage, it will take only 1.19 years. So that is the question.